Classes and objects in C++. In this video, you will learn about classes, learn about private, protected, and public members of a class, explore how classes are implemented, become aware of accessor and mutator functions, and examine constructors and destructors of a class. Previously, we introduced a problem-solving methodology called Object-Oriented Design, or OOD. In object-oriented design, the first step is to identify the components called objects. An object combines data and the operations on that data in a single unit. In C++, the mechanism that allows you to combine data and operations on that data in a single unit is called a class. Now that you know how to store and manipulate data in computer memory and how to construct your own functions, you're ready to learn how objects are constructed. This and subsequent videos develop and implement programs using object-oriented design. This video first explains how to define class and use it in a program. A class is a collection of a fixed number of components. The components of a class are called the members of the class. The general syntax of a class starts with the keyword class, and then the class name, which can be any legal identifier in C++, then open curly braces, and then you go through all the class member lists, closing curly braces, which defines the scope of the class, and then termination. Class members can be a variable or a function. If a member of a class is a variable, you declare it just like any other variable. Also, in C++ versions prior to C++ 11, in the definition of the class, you cannot initialize a variable when you declare it. If a member of a class is a function, you typically use the function prototype to declare that member. If a member of a class is a function, it can directly access any member of the class. Member variables and member functions, that is when you write the definition of a member function. You can directly access any member variable of the class without passing it as a parameter. The only condition is that you must declare an identifier before you can use it. There are three categories of class members. In C++, private, protected, and public are reserved words and are called member access specifiers. By default, all members of a class are private. If a member of a class is private, you cannot access it directly from outside of the class. A public member is accessible outside of the class. To make a member of a class public, you use the member access specifier public with a colon at the beginning. Very soon we're going to look at these in a code example. But before we start coding, let's talk about how to design a class. A class and its members can be described graphically using a notation known as the Unified Modeling Language, or UML notation. For example, a UML notation, as you can see in this slide, is defining the class clock type. The top box contains the name of the class. The middle box contains the member variables and their data types. The last box contains the member function name, parameter list, and return type of the function. A plus sign in front of a member identifies that member is a public member, as you can see here all the way down. A minus sign, as you can see up here, goes in front of a member and indicates that the member is private member. The symbol pound that you don't see it on this diagram, if goes before the member name, indicates that the member is a protected member. Okay, now it's time to go and create our first class in this video. There are multiple ways and locations that you can create your class and put the code in. One of the usual ones is to start creating the class right before main in your main file. But I'm going to go with the more robust way of defining the classes, which is defining them within their own individual standalone file. To do so, I'm going to go to the Solution Explorer on the left side of the Xcode and right-click on Classes. And over there, what I want to do is choose New File. From the new file, I'm going to use Mac OS and C++ type of file and click on Next. Then I'm going to name it. In this case, what I'm going to create is a class called ClockType. So I'm going to name it ClockType. Okay. Notice that I'm checking also create a header file over here, and then I click on Next. In the next step, what I need to do is I need to define where this file is going to be saved. I'm not going to change where it is, which is going to be right under the classes folder where the main.cpp is, which is the best practice, and I'm going to click on Create. Now, as you can see, two files are created for me. One says ClockType CPP and the other one says ClockType HPP. One is the header file or .h and the other one is the implementation file or .c, where I'm going to explain those very soon. So to begin with, I'm going to go to the header file, which is the HPP over here, and right after where I have include stdio, I'm going to start developing my class. Okay, so the first step, as you remember, was using the keyword class. And then next thing is to define the identifier for this, which I'm going to call it the class type. And then as I said, we have the curly braces over here. And here it is. This is the basis of my class. Okay, then what I'm going to do is I'm going to start with the public members of this class. And when I want to do this, I need to remember the design that actually I had in the UML. So let's quickly go back to the UML, look at it, and then come back here and continue. Okay, we're back into the UML. Let's just look at this. We have three private members, which are hour, minutes, and seconds. And then we have about 7 different public functions, which are set time, get time, print time, increment seconds, increment minutes, increment hours, and last but not the least, equal time. So what I'm going to do right now is in the public section, I'm going to create all the prototypes related to the UML that we just reviewed together. Now that I have all the public prototypes, it's time to go ahead and define all the private members for this class. If you remember, there was an hour, so I'm going to add the hour. There was a minute, so I'm going to add the minute. And there is a second, which I'm adding it right over here. Okay, so we're almost done. Let's review what we did. The class ClockType has 7 member functions. We just defined all those. It has 3 private member variables, hour, minute, and second. Notice that the 3 member variables are private to the class and cannot be accessed outside of the class. And the 7 member functions are public and can be directly accessed outside the class. They can also directly access the member variables hour, minute, and second because they are within the same scope. In the other words, when we write definitions of these functions, we do not pass these member variable parameters to the member function because they already have access. Again, remember, these are just prototypes, so anything that you see over here as a function prototype and needs to be defined. And the function equal time, which is a Boolean function, the formal parameter is a constant reference parameter. That is, in a call to the function equal time, the formal parameter receives the address of the actual parameter, but the formal parameter cannot modify the value of the actual parameter because of the keyword constant. You could have declared the formal parameter as a value parameter, but that would require the formal parameter to copy the value of the actual parameter, which could result in poor performance because you're going to be using double the memory. Okay? If you don't remember this and how the pass by reference works, please refer back to the previous videos where we compared pass by value versus pass by reference, and after that come back and continue here. The keyword constant at the end of a member function, get time, print time, and equal time specifies that these functions cannot modify the member variables of a variable of type clock type. So it is important to remember what that means so that when we implement it, we have it in mind and follow the design. Couple of notes here. Remember, the private and public members can appear in any order. If you want, you can declare the private members first and then declare the public ones. It doesn't really matter. Also note that in the definition of the class clock type, all member variables are private and all member functions are public. However, a member function can also be private. For example, if a member function is used only to implement other member functions of the class and the user does not need to access this function, you can make it private. Similarly, a member variable of a class can be public. Once a class is defined, now you can declare a variable of that type. In C++ terminology, a class variable is called a class object or class instance. To help you become familiar with this terminology from now on, we will use the term class object or simply object for the class variable. The syntax for declaring a class object is basically same as that for declaring any other variable in C++. So as you can see on this slide, you simply use the data type, which in this case is clock type, and then name your object. Each object can have different members. In this case, each object has 10 members, 7 member functions, and 3 member variables. Each object has separate memory allocated for their hour, minute, and second. Before we move any further, let's go to the code and define an object and get introduced into the concept of including a header. So if I go back to the code, I need to go back to my main, and within main, if I want to define an object of clock type, basically I have to go ahead and type in clock type and name of the object, which in this case we said we're going to call it my clock, right? But if you noticed, clock type is not understandable for my main as of right now. The reason is the file that has that header, which is clocktype.hpp, is not known to the main. In order to fix this issue, I need to go ahead and include clocktype.hpp. Notice the syntax for the name is exactly as the file name over here. After we include that, as you can see now, clock type my clock is being known. And from this point on, if I use clock type, I have access to all the 7 member variables, okay? So we're going to come back here and discuss on how to work with the objects. For now, just notice that in order to use this data type in here, we need to basically include only the header file, not the CPP, and we're going to discuss the implementation of CPP later down in this video. But for now, notice only .hpp is good enough to be included on the top, and now I have access to clock type and I can create as many clock types as I want over here. It can be my clock 2 or whatever, and so on and so forth. So speaking of memory allocation, in actuality, memory is allocated only for the member variables of each class object. C++ compiler generates only one physical copy of a member function of a class, and each class object executes the same copy of the member function. So because of the fact that member functions do not get repeated, whenever we draw the figure of a class object, we will show only the member variables. As you can see on this slide, we have my clock as an object over here, and we have your clock as an object over there. And our drawing only shows the private members which are dedicated to these specific objects. as the other member functions are common between those two, so we don't repeat them down here. Now let's see how we can access class members. Basically, once an object of a class is declared, it can access the members of the class. The general syntax for an object to access the member class is, as you see on this slide, class object name using the member access operator, which is dot, and then we call the member name. Okay? Remember, the class members that a class object can access depends on where the object is declared. If the object is declared in the definition of a member function of the class, then the object can access both the public and private members. I will elaborate on this when I write the definition of the member function equal time for our class clock type. Okay, so bear with me on that. If the object is declared elsewhere, for example in user's program, then the object can access only the public members of the class. Let's go ahead and try some examples. Okay, I'm going to get rid of one of these and I'm going to create a clock type. As you can see, you get suggestions, right? So you can use those suggestions to fasten your process. And this time we're going to have a your clock. So two clocks object defined. One is my clock, the other one is your clock. Let's do this. Let's do my clock, okay? And using the dot operator, I want to call the member function set time. Notice that when I'm choosing set time from the list that is being suggested to me, it is giving me a copy of the prototype over here, okay, which is telling me it needs 3 integers. What I'm going to do is I'm going to set these 3 integers to 5, this one to 2, and this one to, let's say, 30. Okay, it's 5, 2, and 30. This basically is calling that function. Let's say I'll do your clock, and again I'm going to call set time. I want you to notice as soon as I hit on the dot, a list of available members is being shown to me. If you look at this, hour and minute down here are scratched out with red because those are private members and I cannot directly access them over here. However, all these other 7 functions are available to me through public identifier that they are underneath. So what I'm going to do here is, let's say, set time, this time to, I don't know, 10 and 2 and 30 seconds again. For some reason, I love 30 seconds. And now I can call any other function that I have over there, like my clock dot print. Okay, it's going to print it. As you know, we haven't defined the details of those functions yet. Those are still in prototype stage. However, I can still use them without any problem, even though they're not fully defined. Okay, now that we are here, let's try some illegal assignments. So let's look at this. If I use my clock and want to use setting the hour to 5, this is illegal, as you notice, because hour is a private member. I cannot access it over here. I can access it within the function, with the public function within the class, but not over here, as because my clock is defined outside the scope of that class right now. Most of C++'s built-in operations do not apply to classes. You cannot use arithmetic operators to perform arithmetic operations on class objects unless they're overloaded, which we will talk about this later, not in this video. For example, you cannot use the operator plus to add 2 class objects of, say, type clock type. Also, you cannot use relational operators to compare 2 class objects for equality. Again, unless those are overloaded, which is a different discussion that we're going to take care of it in future videos. The 2 built-in operators that can be applied and those operations related to them are valid for class objects are One, member access operator, which is the dot operator, and two, the assignment operator. Let's talk about the assignment operator in a class. Suppose that my clock and your clock are clock type objects as defined previously. Furthermore, suppose that the values of my clock and your clock are as those are shown in this slide. We can write a statement saying my clock equals your clock. Let me show you how we do this in the code. It is as simple as calling the first object name, which is my clock, and then use the equal sign, and the second object name, which in this case is your clock, and terminate the line. And before we get off here, let me just delete this illegal line to avoid those errors. So let us go back to the slides. Again, suppose that the values are what you see on the slide. The statement my clock equals your clock copies the values of your clock into my clock, which is the value of your clock.hour is going to be copied to the value of my clock.hour, and then the value of your clock.minute is going to be copied over to my clock.minute, and then the value of your clock.second is going to be copied to the value of my clock.second. As you can see, it's more like a member-wise copy. The same member is going to copy over the same member. In the other words, the values of three member variables of your clock are copied into the corresponding three member variables of my clock. Therefore, an assignment statement performs a member-wise copy. Before we move any further, let's talk a little bit about the class scope and actually how a class scope is affecting an object. A class object can be either automatic, that is created each time the control reaches its declaration, and destroyed when the control exits the surrounding block or scope, or the object can be static, that is created once when the control reaches its declaration and destroyed when the program terminates. Also, you can declare an array of class objects. A class object has the same scope as other variables. A member of a class has the same scope as a member of a struct. That is, a member of a class is local to the class. You can access a class member outside of the class by using the class object name and the member access operator. This slide shows the rules describing the relationship between functions and classes. So class objects can be passed as parameters to functions and returned as function values. As parameters to function, class object can be passed either by value or by reference. If a class object is passed by value, the contents of the member variable of the actual parameter are copied into the corresponding member variable of the formal parameter. Recall that when a variable is passed by value, the formal parameter copies the value of the actual parameter. That is, memory space to copy the value of the actual parameter is allocated for the formal parameter. As a parameter, a class object can be passed by value. Suppose that a class has several member variables requiring a large amount of memory to store data, and you need to pass a variable by value. The corresponding formal parameter then receives a copy of the data of the variable. That is, the compiler must allocate memory for the formal parameter so as to copy the value of the member variable of the actual parameter. This operation might require, in addition to a large amount of storage space, a considerable amount of computer time to copy the value of the actual parameter into the formal parameter. On the other hand, if a variable is passed by reference, the formal parameter receives only the address of the actual parameter. Therefore, an efficient way to pass a variable as a parameter is by reference. If a variable is passed by reference, then when the formal parameter changes, the actual parameter also changes. Sometimes, however, you do not want the function to be able to change the value of the member variables. In C++, you can pass a variable by reference and still prevent the function from changing the value by using the keyword constant or const and the formal parameter declaration. And this is what we did over here. Notice that we are receiving a reference over here, and this is what the ampersand is signifying. But the keyword constant protects that referenced object so that equal time is not able to change it. Now we are ready to start implementing the member functions that we defined as prototype. When we defined the class clock type, we included only the function prototype for the member functions. For these functions to work properly, we must write the related algorithms. One way to implement these functions is to provide function definition rather than the function prototype in the class itself. Unfortunately, the class definition would then be very long and difficult to comprehend. Another reason for providing function prototypes instead of function definitions relates to information hiding. That is, we want to hide the details of the operations on the data. I will discuss information hiding later down the road. Next, we have to write the definition of member functions of the class, which means we will write the definitions of the functions set time, get time, print time, increment seconds, equal time, and so on. Because the identifiers set time, print time, and so forth are local to the class, we cannot reference them directly outside the class. In order to reference these identifiers, we use the scope resolution operator or double colon. Okay, let's see how it actually happens. So going back to the code, I want you to look at the Solution Explorer and choose the clock type.cpp, which I mentioned previously. It's going to contain the definition of everything that we declare within the clock type.hpp. As a guide, I'm going to copy these guys from here, come over to this file, delete these comments, and paste them on the top and actually comment them all out. Remember, I'm just using them as a reference over here so you can see what we're doing. Just remember, all of these are copied from the header file. For the rest of the file, if you notice, I already have the include clock type.hpp, which is the header. You already know why this is happening over here, okay? Sometimes you need to go ahead and include, pound include the IO stream over here, okay? If you're using IO stream, so you do it. Sometimes you do the using namespace standard over here if you have input outputs. So on and so forth, the same thing that you used to do in coding happens over here. This is your implementation. Okay, now I'm going to go ahead and define function set time. So look at the syntax. Function set time up here shows me that the return value is void. So I'm going to keep void, right? Because we have to keep the signature. And now I need to define where that set time comes from. So that is coming from the class type, right? And notice that I have double colon as the scope resolution operator over here, right? Now it's time to use set time. And as you can see, I have suggestion for set time, which I'm going to use that suggestion. Now I have to go ahead and put the curly braces right there, okay? And this is basically a part of the function. But to implement it more, now I have to define what is that integer. I'm going to name it integer hours. So formal parameters are now being defined, right? Integer minutes. And then finally I have integer seconds. And now I'm ready to define what's going to happen, okay? So putting some safeguards, I'll check to see if the hours that I'm receiving is between 0 and 24. Remember, Here, I can make sure the information that is being passed is actually valid. So if the hours is greater than 0 and hours are less than 24, that is my acceptable range, right? Then what I'm going to do is I'm going to set the HR to be equal to hours. As simple as that, okay? So else, what I want to do is I want to set, looks like my control is jumping. So I'm going to set hour to be 0. That's simply setting the hours. Okay, let me just fix this guy pretty quick. There we go. And now it's the time to set the minutes and the seconds up. Let me just quickly do that. And now we have the complete definition of set time. Note that the definition of function set time checks for the valid values of hours, minutes, and seconds. If these values are out of range, the member variable hr, min, and sec are initialized to 0. And if not, then the correct value is going to be set. Let me explain how the member function set time works when accessed by an object of type clock type. Okay, remember that the member function set time is a void function and has 3 parameters. Therefore, a call to this function is a standalone statement, and we must use 3 parameters in a call to this function. So basically, when we call the function, we have to pass 3 parameters. Furthermore, recall that because setTime is a member of the class clock type, it can directly access the member variables hour, minute, and second, as we discussed before. Okay, let's go to an example and analyze more how this actually works. Okay, we're back to the slides. So suppose that my clock is an object of type clock type as declared previously. The object my clock has 3 member variables as you can see on this slide, okay? And those are empty, nothing is there. And then we run the call my clock.setTime to 3:48 and 52, okay? When we run this statement, the function setTime is called with parameters 3, 48, and 52. So the values of the formal parameter hour, minute, and seconds of the function setTime are now set to 3, 48, and 52 respectively. Okay. Next, in the statement myClock.setTime 3:48:52, setTime is accessed by the object myClock. Therefore, the 3 variables hour, minute, and second referred to in the body of the function setTime are the 3 member variables of myClock. When the body of the function setTime executes, the value of hours is copied into myClock.hour. The value of minutes is copied into myClock.minute, and respectively, the value of second is copied into myClock.second. In essence, the values 3, 48, and 52, which are passed as parameters and the preceding statement, are assigned to 3 member variables of my clock by the work of function setTime. After this statement runs, then my clock object is now full and goes as you can see over here. Let me just quickly go back to code. Remember, hour, min, and second are private members of the function. They're not directly accessible, right? But the formal parameters hour, minutes, and seconds that we pass to the public function of setTime can actually fill in on those variables. So these 3 private members are accessible through calling this public function. Okay, here simply is the definition of getTime. As you see, we're getting integer references to hours, minutes, and seconds, and what we do is we set those hours, minutes, and seconds to be equal to the hr, min, and sec of the current object. Simply user provides 3 members and we just send it back. Next in the row is going to be print time, and here it is. As you can see, again, we have some checks. which basically makes sure that we are showing the right format of the hour. So you see when hour, minutes, or seconds are less than 10, basically we show 0, and then we move on and show the other one to show 12-hour format. I will simply add the rest of the code and leave you guys the code so you can look at it if you want. The rest of it is nothing but defining the functions, and you already have done a lot of practice on defining the function. So let me just put the code in, and then we come back and discuss them more. The one that I actually want to emphasize on is going to be the equal time, which we're going to get there. Just give me a moment to put the code in. Okay, all the code in. While coding, I noticed that I missed adding this prototype, increment hours. And if you go back through the videos and don't see this in the previous minutes of the video, it's just because I forgot to put it in. I don't know how I missed it, but anyway, we needed an increment hours, so I added this prototype over here. And now let's go to the implementation. We already discussed set time and get time, so I'm going to leave them. We talked about print time. That's again very clear. We have 3 increments here: increment hour, minutes, and seconds. Notice that in each one we are checking if we need to increment the previous bigger one. What I mean is, look at increment second over here. We do second plus plus. If second is greater than 59, what we do is we set the second to be 0, but then we increment the minute because logically it is 60 seconds and we need to add 1 to minute. And notice that this one is being called right over here at line 63. And then same story happens within the increment minute. When the minutes exceed 59, they arrive at 60 minutes. We need to increment the hour, and that's why line 53 is calling for increment hours up here. So notice that we can call a function from within another function if need be, as long as they are within the same scope, okay? But let me get down to what I really like to talk more about over here, which is the equal time. And implementation on equal time is we receive a constant object reference of the same class type, which is clock type. And what we do is we return hour to be the other clock.hour, minute to be the other clock.minute, and second to be the other clock.second. If you note what's going on here, we are receiving an other clock, and we are running this function as a member function of the current object. And if the hours, minutes, and seconds of other clock and the current object are the same, the result of this and I can do it like this, so it's actually a little bit more readable. I think this way you can see what is exactly happening. So if the result of this and is true, then we return true, which is the Boolean return value of this function, which is going to tell us, okay, these two clocks that we are comparing are now equal. And if it returns false, then that shows these are not equal. So hour to hour, minute to minute, and second to second is being compared. Let's discuss this even further. So let's go to main and check this. So what I want to do is I want to write a statement saying if my clock dot equal time, and over here I want to send your clock to this, okay? And in that case I want to say, okay, cout equal, and I'm keeping it simple, okay? So else is going to be a cout unequal, right? So very simple. Okay, that's basically how I use that function. Let me just go to the slide and discuss that. So consider the statement that we put down, which was my clock that equal time your clock. In this expression, the object my clock accesses the member function equal time because other clock is a reference parameter, the address of the actual parameter your clock is then passed to the formal parameter other clock, as you can see here on the slide, right? The member variable hour, minute, and second of other clock have values which are 14, 25, and 54 respectively. In the other words, when the body of the function equal time executes, the value of other clock.hour is 14, the value of other clock.minute is 25, and the value of other clock.second is 54. The function equal time is a member of my clock. When the function equal time executes, then the variables hour, minute, and second in the body of function equal time are member variables of object my clock. Therefore, the member hour of my clock is compared with other clock.hr. The member minute of my clock is compared to other clock.minute, and the member second of my clock is compared to the other clock.second. Once again, from the definition of function equal time, it is clear why it has only one parameter. Let us again take a look at the definition of function equal time. Let me quickly go back to code and go to the definition of equal time, which we have it down here, okay? Notice that within the definition of this function, the object other clock accesses the member variable hour, minute, and second. However, these member variables are private. So is there any violation here? The answer is no. The function equal time is a member of class clock type, and hour, minute, and second are member variables. Moreover, other clock is also an object of type clock type. Therefore, the object other clock can access its private member variables within the definition of function equal time. The same is true for any member function of a class. In general, when you write the definition of a member function, say my function of a class, say my class, and the function uses an object, I don't know, dummy object of the class, dummy class, then within the definition of dummy function, the object dummy object can access its private member variables. In fact, any private member of the class is accessible. Once a class is properly defined and implemented, it can be used in a program. A program or software that uses and manipulates the objects of a class is called a client of the class, or sometimes we call it a user of the class. When you declare object of class clock type, every object has its own copy of the member variable hour, minute, and second. In object-oriented terminology, variables such as hour, minute, and second are called instance variables of the class because every object instance has its own copy of these data. Okay, so far so good. So next logical step in defining a class is defining the accessor and mutators for that class, or generally speaking, setters and getters of the class. So functions such as getTime, printTime, and equalTime that we defined so far, they only access the values of member variables. They do not modify the member variables. We can therefore categorize the member functions of the class clockType into two categories: member functions that modify the member variables and member functions that only access but do not modify the member variables. This is typically true for any class. That is, every class has member functions that only access but do not modify member variables, called accessors, and member functions that modify the member variables, called mutators. So, accessor function is a member function of a class that only accesses, and mutator function is a member function of the class that modifies the values, as simple as that. A member function of class is called a constant function if its heading contains the reserved word constant at the end. For example, if you remember, the member functions getTime, printTime, and equalTime of the class clockType were constant functions. Let me just show you pretty quick so you can Remember those member functions. So look at this. When you have the const over here or const over here, you're dealing with a constant function. Usually, when you want to initialize an object, you use a function called a constructor. We use constructors to guarantee that member variables of the class are initialized. The role of constructor is initializing an object when creating an object. Constructors have some very specific properties. There are two types of constructors. One is with parameters and the other one is without parameters, which is actually the default constructor. This is the constructor that automatically gets generated by the compiler if you do not define yours. Okay. What is very important to understand is the name of the constructor is the same as the name of the class. Also, you have to know that a constructor is a function and it has no type. This is the only function that has no type. That is, it's neither a value returning function nor a void function. You're going to see this better when we go back to the code. A class can have more than one constructor. However, all constructors of the class should have the exact same name. And I know it may be odd to you right now because of the applications, but when we go back to the code, you're going to see it in action. If a class has more than one constructor, the constructors must have different formal parameters list. That is, either they have a different number of formal parameters, or if the number of formal parameters is the same, then the type of the data and the formal parameters must be different. Constructors execute automatically when a class object enters its scope. They cannot be called like other functions. Remember, those are creators of the objects of the class. So there is no object that you can call this constructor as a member of that object. Those are initially generating the objects themselves. Which constructor executes depends on the type of the values passed to the class object when the class object is declared. And remember, when the data types are different or the number of parameters are different, then based on how you call the constructor, the respective constructor is going to be called. A constructor is automatically executed when a class variable is declared, and because a class may have more than one constructor, you can invoke a specific constructor whenever you want. Okay, code time. Let's go to the main first and look at lines 8 and 9. This is basically how you invoke the default constructor. Notice that we are not passing anything to these, we're not passing no parameter, okay, to this object initiation. Default constructor is being called like that. Now going back to the header file, I want to show you how we can create a prototype for the constructor, okay? The constructor usually must be public because you want to create an object off of it from a client place or a user code, right? And that means you should have access to it. So, rule number one, the name of the constructor must be exactly the same as the name of the class. Therefore, we already know it should look like this, right? And then you decide what do you want to pass to it. In this case, let's say we want to have a constructor that actually creates an object of clock and initializes hours, minutes, and seconds, and this is going to be the prototype for that. Now, let's say I'm going to have another constructor that doesn't receive no argument. Notice that the name for both of them is the same. There is no return value. It's very important. There is no return value for the constructor. It actually returns an object, right? But the number of parameters and the type of them must be different. So if I want to have a constructor like this, as you can see, I have the same number of input parameters, but the type is different. It is still acceptable. But if I go ahead and define another one like this, then this is not acceptable. You cannot have the exact same name repeated with the exact same number and the type, okay? So we cannot declare it twice. Very simple. Remember, as soon as you create your own constructor, which is what we did over here, then the default constructor is not going to work anymore. So you have to define it, and this is what I'm doing. I'm doing this, so I'm redefining the default constructor. So for definition, I'm going to go to the CPP file. Let's go to the bottom of it so we have a clear place. So as you remember, there is no return type, so I can simply just use the scope identifier and this, and I have my constructor already ready to go. Okay, so what I'm going to do is I'm going to go ahead and call integer hour, integer minute, and integer seconds, right? Let me just go ahead and make them a little bit distinct. I don't want to create no confusion. And then boom, done. Here is my constructor, okay? Here's my default constructor. And the thing is, I can actually cheat and go up here, and the same code that I have for the set time can actually work for my default constructor. Remember what my default constructor does, and I just need to check these to be exactly the same, not to get any error. There we go. So within this constructor, I'm doing the same thing as setting it to clock, right? Setting a time. There you go. The time is set over there with the same rules, and my default constructor is now ready to go. The next constructor that I need to define now after I started defining my constructors is the default constructor. And I'm going to do it like this, and in the definition portion of it, I simply set the hour to be 0, set the minute to be 0, and remember, this is when user is not passing me any parameter, right? So it makes sense to set everything to 0. So the default constructor is going to create a clock which is starting at 000, and the 3 arguments constructor, and we call this a 3 args constructor because it has 3 arguments, is basically and simply create a clock object with the hour, minute, and second set up as the values are passed to it. Let's see how we actually now call these constructors. Now that I have both of them set up, I'm going to go back to main, and this time I'm going to create an object using these constructors, okay? So to invoke this, I start with the clock type, name of the class. That's again the data type that I have to do. And now I'm going to use my object name, which in this case I'm going to do, let's say, test clock. And I'm going to pass 10, 10, and 10 to it. So you see the difference between calling and invoking the constructor through passing all the arguments or passing no arguments there, okay? This goes to the default constructor. This goes to the 3 args constructor. I believe it's very simple and easy. Let's go back again and take a look at the definitions over here. Here I have the 3 args constructor defined, which receives the hour, minutes, and seconds and just adds them over there. And here I have the clock type. Okay, so I want to re-emphasize that if a class has no constructors, C++ provides the default constructor which does not initialize the object. But if a class includes constructors with parameters but not the default constructors, then C++ does not provide the default constructor. And you need to manage it as we actually did here in the code. That's why we manage the default constructor ourselves. The next logical step is talking about destructors. Like constructors, destructors are also functions. Moreover, like constructors, a destructor does not have a type. That is, it's neither a value returning function nor a void function. However, a class can have only and only one destructor, and the destructor has no parameters. The name of the destructor is the tilde character followed by the name of the class. For example, for our class, the name of the destructor would be a tilde clock type. The destructor automatically executes when the class object goes out of the scope. The use of destructors will be discussed in near future, but for now, think about if you want to do something when the object is going out of the scope, like showing a message, then you can use the definition of a destructor and put it in there. Let me just take you to the code. I already took the liberty of defining one. Line 28 is how you define the destructor. Tilde clock type, that's the prototype for the destructor. And if we go to the clock type CPP, here is the implementation of your destructor. As you can see, for this example, I just put the cout in there, which says the object is deleted. We will discuss this in more details. I believe at this point we can end this video. This is all we needed to talk about when it comes to the classes. Remember, there are more concepts to learn about the classes and objects, such as data abstraction, abstract data types, inheritance, polymorphism, and so on, which will follow in the coming videos. Thank you for watching this video, and we close this video here.